Hi everyone, and welcome back to chemistry. This is Mrs. Hutchinson again, and today we're going to be learning a little bit about scientific thinking. So don't forget that as you are copying the notes, if I'm going a little too fast, that you can pause it to copy all of the notes down. I hope this gives us a little more insight into our current way of how we do science. So science hasn't always been the way that we do it today. In fact, before the 1500s, before the Middle Ages, religious scholars decided what was true and what was false based upon either religious books or their own thinking. Very few scholars actually observed nature by themselves, which kind of made it a little hard to figure out what was true and what was untrue. Now, the scientific revolution took place in the late Middle Ages, and it actually occurred because people finally were willing, to question the accepted beliefs of their scholars. This was something that wasn't really done often, and it was eventually done in the late 1500s. Since they questioned the accepted beliefs, they now based their beliefs based upon careful observation of the world around them, as opposed to what somebody simply just told them. Scholars in the late Middle Ages, in the 1500s, translated works from Muslim scholars and actually figured out that we already know a little something about astronomy, and physics and mathematics, which is good. Muslim scholars figured that out for us. Now, way back when, during the Renaissance, authorities really didn't often agree with one another in terms of what was scientifically true and what was scientifically untrue. Now, during the Age of Discovery, which took place in the 1400s to the 1600s, we discovered, or new cultures, were discovered. We had the African cultures, Asian cultures, the Americas, and Europeans now found that there were new ideas for how the world was interpreted by different cultures. And it really wasn't until this guy named Gutenberg came up with his printing press in the 1440s, and this allowed our ideas, or scientific ideas, or religious ideas, to be spread throughout the entire world, because it was a way to get information out quickly. Now, new inventions needed to be created to help guide our explorers. So this actually helped increase our scientific thought at that particular point. Mainly because of the fact that without these new inventions, our navigators, our explorers, they're not going to be going anywhere because they're not going to know where they're going. And what was really found with these new inventions and new explorations was that the world that people had known it way back when didn't match what they had been believing for a long time. So we had to really figure out how to change that, how to discover what's actually happening scientifically. So we have a new approach. This is where, in the 1600s, we finally started taking into consideration observations and experimentations. So our scientific method. We started to really observe the world around us and experiment whether or not what we observe happens just that one time or if it actually happens all of the time. And we now started to move science away from philosophers and our religious books. Now, Newton, he was the first guy, in case, I don't know, maybe you've heard of him, his name is Isaac. He used math to show that there is a single force that keeps the planets in orbit. That force you may have heard of is known as gravity. What he did was he basically observed, why aren't people or objects, why don't they float up? How come whenever we let them go, they just fall? So he started to really experiment with that and see if that was always the case with every single object. And he was able to calculate the force or acceleration due to gravity. He also came up with three laws of motion. Now, I think you've heard of them. The first law is the law of inertia. Something that has more mass is going to take a lot longer to stop because it has more inertia. We also have our second law, force equals mass times acceleration. And our third one is, for every action, there is an equal and opposite reaction. So his way of thinking really helped us move forward in our scientific revolution. Chemistry, we actually didn't do much with chemistry because at first chemistry was a little hard for the scientists to explain because they thought that chemistry is basically alchemy. What alchemy is that you can take an ordinary metal, such as lead down here, and we can turn lead. I don't understand why that's happening. So we can actually turn lead, according to alchemists, into gold. We basically take this metal that's not really worth much of anything, and just by heating it up or doing something to it, we can turn it into gold. Now, back then with the instruments that they had, alchemy like this was not really possible. However, on your worksheet, there is an article that you're going to be reading that deals with current alchemy, and it's quite interesting. So, also, this guy named Robert Boyle, he was really the first to show differences between elements and compounds. Now, there were plenty of people before him to discover, hey, our world is made up of elements, but their idea of elements were very different from our current thinking of elements. But he was the guy to figure out, hey, there are elements that make up compounds. And his work actually led to our modern chemical analysis of matter. So he's kind of an important chemist. He also has a law that's named after him for gas laws. So, medicine. Medicine was also quite an important thing for the scientific revolution. So, during the Middle Ages, this guy named Galen had very limited knowledge of human anatomy, which basically meant if you had to have surgery on something, if you had to have a bone set because you broke it, the doctors were kind of guessing what needed to actually happen to you, and they would just try it. Kind of scary. It wasn't until this very famous Renaissance artist came along. Leonardo da Vinci was actually much more of a scientist. He would deal with cadavers and he would examine the anatomy of the human body. And he made these very detailed drawings right here of how the human body was connected and what made up the human body. He was the first to really kind of dive into anatomy, which is kind of cool, actually, because many people just think of him as an artist as opposed to a scientist. We also have Versailles. He published a book that accurately depicted the details of the human anatomy. So we had Da Vinci discovering and drawing pictures, and then this was the first person to actually write a book on it. We also have, and I can't pronounce this name, Ambroise Paré, maybe, or Père. We can Americanize it and say Père. He developed an ointment to prevent infections, which was huge because not only were the doctors just guessing back then, but they would just open you up, try and do what they thought they needed to do, and then either leave you open and hope that the wound would heal, or kind of stitch it together haphazardly. And lots of times the wound would get infected. So this guy was the first one to really discover and use antibacterial ointment. And he also came up with a better technique for stitching wounds together. William Harvey discovered how the heart pumps and how veins and arteries are attached, which is huge because, well, without that, if you needed anything to do with your heart, we wouldn't really know what was going on. So all of those people contributed to the scientific revolution. Science really took on a whole new level at that particular time because now people are starting to observe the world around them, starting to dive into cadavers, starting to figure out why things fall. And they all did this using a method known as the scientific method. Francis Bacon and René Descartes, they both agreed that truth isn't known at the beginning of inquiry, but rather at the end of an investigation. So this was very, very different from where we were with the scholars. Scholars just believed that truth is truth, and that's what I'm going to tell you, whether or not I have any proof for it. So Bacon stressed, again, here are our major terms, experimentation and observation. And he wanted, what he was hoping for, was that science would make life easier and better for people using practical technologies, which I think you can think of the way science has improved life today. First of all, with this video, pretty stinking cool. Without science, we wouldn't have computers and iPads or cell phones and things like that. So Bacon was kind of right. Now Descartes, he said that human reasoning was the best method for understanding. Basically, when you observe something and the reason that you come up with for that observation, why that happened, or why that experiment resulted the way it did, that was the best way of understanding something. And he came up with this very, very famous saying, I think, therefore I am. Maybe you've heard of it. It's quite an important saying, so I really want you to think about it, look it up, figure out what it actually means. But he stated that through reason, as opposed to just simply religious books or traditional sources of knowledge, people could finally discover what is true. So now let's get into the scientific method itself. The scientific method is designed in such a way that you have a methodical way of finding an answer to any problem. Basically, you'll follow the same procedure every single time, and that will lead you to a scientific understanding of the problem at hand. So the scientific method also gives scientists a way to take full advantage of accidental discoveries. In fact, there are so many accidental discoveries that on our worksheet, you're going to write about some of them and read about some of them, because without these discoveries, our society would not be where it is today. So the worksheet that you're going to work on looks a little something like this. It's called the History of Scientific Thinking Worksheet. You're going to answer all the questions. There are a couple of links to articles that you will have to read and answer some questions regarding those. But it's actually quite interesting because we learn about current alchemy, and we learn a little bit about some accidental discoveries that have advanced our society above and beyond what scientists thought could ever be done at that particular time. So go ahead and start that worksheet, and I will see you the next video.